My name is Daniella, and today I'm going to talk to you about my experience with functional programming. The title of today's talk is FP, the good, the bad, and the ugly. So let's start. First of all, a little bit about me. My name is Daniela. I am a software engineer living in London. But I'm actually Italian. I moved to the UK roughly 10 years ago, and we will see how this will affect my story. I started my career as a Java developer. Scala wasn't my first language. I do not have a degree in mathematics. And I absolutely love Scala. I tend to do a lot in the Scala community. I am an open source maintainer, so I have a couple of libraries that I like to contribute to. But I also have recently decided to write a book that is titled Get Programming with Scala by Manning, which is example driven introduction to Scala and functional programming. So if you are starting off with Scala, check it out, and there is also a discount code of 35% off for you on the screen. But enough about me, let's start talking about functional programming. And as I mentioned it before, I am Italian, so I'm going to use one of my favorite movies that the Italian has produced. And this movie was actually a collaboration between several countries. So we had some actors from the US, some from Spain, from Italy. And this movie is titled The Good, the Bad, and the Ugly. It was released in 1966. So recently we have done the 50th anniversary. Director was Sergio Leone, and there is really good music from Ennio Morricone. And the reason why I picked this movie is, if you haven't seen it, watch it. But if you have, you probably know that is the story of how these three cowboys interact each other. So you have the sexy, good-looking cowboy that is always followed by the ugly one, and how they try to fight the bad character in the story. And this pattern is really common in everything in life, right? You have good parts, you have bad parts, and you have ugly parts. And what I want to, the main message of my talk is that no matter what you're doing, particularly in tech, you always have to keep this in mind. You are going to have parts that are good. Those are bits that you like, you even love. You will have parts that are really, really bad that you should avoid at all costs. And there are bits that are not really great, but you kind of need to learn to live with them. So every time somebody in tech introduces you to a technology and they always talk about one of the sides, be aware of it. So when introducing a new technical concept, always ask yourself, are they talking about these three parts, or are they just talking about the good parts, or just the ugly parts, or just the bad parts? So let's start with my functional programming journey, and let's start with the good part, which is why I absolutely fell in love with functional programming, even though I didn't have a background in mathematics. And the main reason why I fell in love with functional programming is because it increased my productivity. By following simple rules, I was able to write code that made me more productive. Let me show you what I mean with an example. So the first principle of functional programming that I would like to talk to you about is about immutability. So on the left side of your screen, you see a simple snippet of code in which the objective is to do something exactly 10 times. So you have a private var I that is initialized to 0, and then you have a while loop where you say while I is less than 10, do some stuff, and then increment my index I of 1. The functional programming equivalent of this snippet of code is to just say, give me all the numbers from 0 till 10, and then for each number you gave me, I'm going to do stuff. And the reason why this makes me more productive is because on the left-hand side, I need to be careful with what I do with do stuff here. I could do something that could mess up the index, and now my function is no longer doing something exactly 10 times. Let me show you what I mean with an example. So if, for example, when I implement my function, I touch the index I, I'm no longer doing my print line exactly 10 times, but I'm doing it way less. In functional programming, this is not possible. I is immutable. You cannot change its value. So it's impossible for me to write code that doesn't respect the initial requirement of this needs to happen exactly 10 times. I'm reading less code. That makes me more productive. The other really important concept that I would like to talk to you about is called purity, which is really the combination of two things. Something being referential transparent, or RTness in short. Something being total. If something is RT and total, then it is pure. But what do I mean with these crazy terms? Well, something that is referential transparent means that it is consistent. If I give the same input to my referential transparent function, I expect always the same output. Its behavior is totally dependent on its input. Totality, on the other hand, is a function that always returns, right? So it terminates, and it always returns with a value. Keep in mind that a value is something that is described by a type. It's not, for example, an exception. Let's try to understand what I mean with this with a few examples. So, is the function that you see on the screen pure? So the function that you see on the screen is just using a very popular Java library and defines a function called +days that takes one parameter n, and then it takes give me the current time now and add n days to it. So is this function referentially transparent, meaning that it only depends on the input that I'm giving to my function? Well, no, because it's also dependent on when I run my function. If I run it today with argument 1, it's going to return the current time with tomorrow's date. If I run it in a week, the result will be completely different. So this function is not referentially transparent, but it is total. This function will always return you a date. It will never throw an exception. So is this function pure? No, it's not pure, because although it's total, it's not referentially transparent. Let's see another example. So we have this function that is called diff, as division. It takes two numbers, and then it divides A divided by B. Is this function referentially transparent? Well, if I give an A and a B, the division between those two numbers will always have the same result, right? So this function is totally dependent on its inputs, and so it is referentially transparent. But is this function total, meaning it always terminates? Yes, it always does. However, what happens if B is 0? if b is 0, we will have an exception thrown. So this means that this function is unfortunately not pure, because it is referentially transparent, but is non-total, because with b equal to 0, it will throw an exception. Now, let's see one final example. And instead of considering the division, we are gonna consider another function that we called sum. So we have a function that calls sum that takes two arguments, a and b, both of type int, and return the type of int. And then we sum a and b. So is this function referentially transparent? Well, yes, because the sum of two numbers is stable, and it only depends on the numbers that I am summing. And is this total? Well, yes, because we will always return a number. We will never throw an exception. So this function is pure. So the trick here is to have your inputs and the type of your output must totally represent the behavior of your function. One last example before we move on. Let's consider this function that you see on the screen that is called foo, that takes a string and returns a unit, and then it has some implementation. What can I say about this function? Well, not much. I mean, I don't know what it does. I don't know what it's doing with this string, if it's saving it to a database, if it's printing it to string, just to the console. I really don't know anything. But let's see as its counterpart when we have a pure style of function. You now have a function that is called foo, that takes a string s and then it returns an int. Of course, we might still have some side effects, such as printing to screen or saving the string to a database, but the expectation is that this function converts my string into an int. What this means is that there is a good chance that I don't need to actually read the implementation of the function to fully understand what my function is doing. As a result, I'm reading less code and more productive, right? So that's great, because I can infer from the signature of the function what is the full behavior that my function does, which is great. Reading less code makes me more productive. But purity has also a lot of other side effects that are really cool. So if you write pure functions, then your functions are going to be more composable, meaning that they are going to be easier to reuse, and they are also going to be easier to test, because they are a lot more control on what they depend on. And what I love to do when I'm coding is to do something that I call puzzle coding, whereas right now I have my type, let's say a string, and I need to somehow arrive and get to an int. What is the function that takes me from my string to an int? And the good news is that IDEs are really good at this, because IDEs can really help us in picking the right functions that takes us from the type that we have to the type that we want. So that's it for the good part of functional programming. And now let's start talking about the bad parts about functional programming. And these are the parts that we need to be aware of and we need to avoid at all costs. For me, the bad part about functional programming was the learning curve. When I started a few years ago in the Scala community, there was, and I think there still is, a lot of confusion between functional programming and categorical programming. Functional programming is the idea of following a set of rules, such as use immutable data, try to write your function as purely as possible, while categorical programming is a fascinating subset of functional programming that is about category theory, things such as monads and functors and optics, and so on and so forth. And I cannot stress this enough. You don't need category theory to write good functional code. But just remembering those simple rules of don't use immutable data structures, try to write pure functions as much as you can, you will go really, really far away. But when I was starting in the Scala community, and in general, when I was talking with other people that are really into pure functional programming languages, the answer was always the same. But monads are easy, right? People were really surprised that I was struggling to understand what a monad was, and the answer was basically monads are easy, right? A monad is just a monoid in the category of endofunctors. And you can probably see where I'm going with this, right? This sentence, although is totally correct, and it took me 6 months to fully understand this sentence, is not really welcoming, right? So you will sometimes find people that will overwhelm you with difficult terms. But you will also find people that will give you abstractions that are not really useful, like they will tell you that monads are just like burritos because you consume the data and you eventually meet the layer that you're interested in. I never really fully understood this one. So you need to be aware of either explanations that are too literal or explanations that are too abstract. And when I found myself in this position, I started to have fun a little bit. So I actually took a picture of my lasagna. I love to cook, and this is a picture of pre-COVID times where we were allowed to have parties. So one evening I cooked a lot of lasagna, which, in case you're not aware, is a typical Italian dish where you layer pasta sheets with tomato and meat and mozzarella. And I asked people, is lasagna a monad, on Twitter, and people actually started debating. And that was intense. So this brings me to my next point, that is, it's really important that we have talks and tutorials for beginners about these things. Having an explanation that, although is correct, is way too technical is not helpful. Having an explanation that doesn't give us any details but just a vague idea of what could be is not helpful. So as a beginner, you have a unique opportunity there, because you still remember how difficult this was to learn. So having people that are not expert giving talks and writing tutorials is extremely important, because you will make sure that your material is accessible to people that were starting up just like you did a few months ago. The other thing that I had to be aware when I started with functional programming, but to be honest with you, this is true in all fields, is the Rockstar developer syndrome. So the Rockstar developer syndrome is just somebody that goes in a room, comes up with a solution, which might even be working to a really complex problem, and then this person doesn't share any details on how this solution was made, of how this solution works. And eventually, this person is going to be the only person that is able to maintain all of this code. And two things can happen. This person is going to be stuck on the project forever. This person is going to be really unhappy, and eventually is not going to remember or realize, is not going to see other parts of the code. And eventually he's going to be really unhappy, and sure, he might even leave the company because he wants a new challenge. If you are an experienced developer, I would suggest not to be a rock star, not to just come up with a crazy solution that uses some crazy category theory tool, but be a leader. So it's okay to use advanced tools on functional programming or even category theory, but make sure that your team is okay with it. Make sure that you explain what is this really powerful abstraction that you have used in your code, because otherwise you will be stuck with that piece of code forever. But let's now move to the last part of the talk, that is about the ugly parts of functional programming. And these are the bits that are not great, but you eventually learn to live with them. And for me, this was essentially to know when to break the rules. Let me show you what I mean with an example. So suppose that we have a case class, which in Scala is just a class that contains some data, and this data is immutable. And we want to convert our case class into an array. Now, the functional programming way of doing this will be to have a function, let's call it toArray, that takes a product. A product is just a fancy way of saying case class in Scala, and return an array that contains elements of any type. So following the rules that we have seen in the previous part of the talk, we are going to use few functions that use immutable data structures. So I have a product, I'm going to do some puzzle encoding. So I'm going to use the product iterator function to get an iterator of any, and then I'm going to use another function toArray to get an instance of type array of any, which is great, right? It's exactly what I want. The object-oriented programming way of doing this would be to see how many fields I have in my case class. That is what the productarity is. Allocate an array of that size, and then use a while loop where I say, okay, for each member in my case class, I am gonna get that piece of data and populate my array with it. So this is exactly what I said at the beginning of the talk that is bad. So we are, again, using mutability, we are iterating, and this is really bad code, right? It's really non-functional. Well, I did some benchmarking and note the big asterisk there. This is not a serious benchmarking. Please don't read too much into it. And I've put the code on the slides just in case you were curious, but basically I had a big case class with a lot of data in it, and then I calculated the average runtime by running my function 1,000 times and then averaging each execution time. I have generated a random example of my case class and run the test. Well, which one do you think was faster? Well, the object-oriented programming one was like 14 times faster than the functional programming one, which is impressive. It's 14 times faster. So what does that mean? Functional programming and the JVM don't always go along. This is the more JVMs upgrades that we get, the better the situation is becoming. But there are some patterns that are much faster if done in an object-oriented programming style. In case you're curious, the problem is that in the specific example that I'll show to you is because we are using an array, and resizing an array, it's an expensive operation. But let's give you one final example. As I mentioned before, I've written a book on Scala. But I also, on my spare time, I love to teach Scala to people. And one of the things that I do is that I show you, look, this is how a map function works. So this is my ideal implementation of a map function. And my ideal implementations of a map function, which is just a function that recursively iterates through all the elements of a list, is that you have a loop function, which is a tail recursive function, just means that it's stack safe, and then you get the head, and then you recursively apply the function to the rest of the tail. And although this code might look scary, if you are used to Scala, this code looks fairly simple, nothing surprising. But again, this is my ideal implementation of the map function. The real implementation of the map function is the one that you see on the screen. And it's really scary. It has this equal nil, it has a release fence, it has a really non-functional while loop over a couple of variables. But what does this mean, right? This is taken directly from the Scala code base. Does it mean that the Scala team is mean and it doesn't like us? No, it just means that for the core collections, it's so important to be performant that having a coding style that sometimes is not as clean or as functional is not that important. It's the most important objective in this case is to be as performant as possible. So sure, let's go with the ugly implementation that is going to make every single list usage for everybody in the community faster. So my suggestion is be aware that sometimes it's okay to break the rules. And the reason why it's okay to break the rules is when you have a really good reason for it. For the Scala team, having the most efficient implementation when iterating through a list, it is a really good reason because it is the library that everybody uses. So unless if the domain of your application requires you to really optimize what you're doing, sure, break the rules, don't use functional programming. Sometimes, using an object-oriented programming style might make your code run faster. But what I would say is that when you break the rules, hide that you have broken the rules, meaning that maybe keep the signature of your function pure, so that the users that are using that function don't realize that you are actually breaking the rules of using immutable data structures and writing pure functions. And they're not going to realize that until they actually see your implementation. So that's all for me. I hope you enjoyed the talk. My name is Daniela Sfregola, and that's my Twitter handle if you want to get in touch with me. Have a look at my book. That's a discount code for you on the screen. And any questions, ping me. I'll be around during the conference. Thanks.